Assalamualaikum warahmatullahi wabarakatuh. Today my group want to talk about scalar and vector in architecture. My name is Nafitra Ain binti Muhammad Aidia Zahar and my metric number is 01DGU21F2020. First, let me tell you what is scalar and vector. First, scalar quantity has magnitude but no direction. Second is, every scalar quantity is one dimension. Next is, any change in scalar quantity is the reflection of the change in magnitude. And the last one is, any mathematical operation carried out among two or more scalar quantities will provide a scalar only. For example, speed, length, area and so on. So that's all about scalar. While a vector quantity has both magnitude and direction, vector quantity can be 1, 2 or 3 dimension. Any change in vector quantity can reflect at a change in direction or a change in magnitude of change in both. The result of mathematical operation between two or more vectors may give a scalar dot product or vector product. For example, this displacement, velocity, acceleration and so on. Thank you.
Hi, my name is Muhammad Farizam bin Razamdan. My matrix number is 01DGU21F2026. Okay, today I will talk about addition and subtraction of vector. So the first method is parallelogram method. First, draw the vector so that the initial point coincide. The draw lines to form a complete parallelogram. The diagonal from the initial point to the opposite vertex of the parallelogram is the resultant. Okay, so for the definition of vector addition is the operation of adding two or more vectors together into a vector sum. The so-called parallelogram law gives the rule for vector addition of two or more vectors. For two vectors and the vector sum is obtained by placing them ahead to tail and drawing the vector from the free tail to the free head. Okay, so for the example of vector addition is to add the vectors x1 and y1 and x2, y2. We add the corresponding component from the each vector. So it's like x1 plus x2, y1 and plus y2. Here's a considered example. The sum of 2, 4 and 1, 5 is 2 plus 1, 4 plus 5. Which is 3, 9. There are also nice graphical way to add vector, and the two way will always result in the same vector. So that's all from me. Thank you.
Hello and Assalamualaikum. My name is Nur Aina binti Amir. My metric number is 01DGU21F2001. I'm from DGU1A, so I will talk about vector cross product of two vectors. This is a lesson explain. Cross product in 2D mathematics, this product learned to a scalar quantity that is given by the product of the magnitude of both vector multiplied by the cosine of the angle between the two vectors. As for the cross product, it is a multiplication of vector that learn to a vector. This is a definition of vector product. The picture on the slide was taken by me. This is the example from the book. So, let me explain the definition of vector product. The vector or cross product of two vectors is a vector whose magnitude is equal to the product of magnitude of the two vectors and sine of the angle between the two vectors. Learning objective. By the end of this section, you will be able to something, which is number 1, explain the difference between the scalar product and the vector product of two vectors. Second, determine the scalar product of two vectors. Third, determine the vector product of two vectors. Last but not least, describe how the product of vectors are used in principle. Conclusion. In short, scalar quantity give you an idea about how much of an object there is, but vector quantity give you an indication of how much of an object there is, and that also in which direction. So the main difference between the two quantity is associated with the direction. Scalar do not have direction, but vector have.
Assalamualaikum, my name is Muhammad Zikrizat Umar Asri and my matrix number is 01DGU101F2015. Okay, today I'm going to talk about the dot production, the vector of dot production. Okay, definition of the dot product is the sum of the products of the corresponding entries of the two sequences of numbers. Geometrically, it is the product of the Euclidean magnitudes of the two vectors and the cosine of the angle between them. If OA equal to A and OB equal to B and tangent is the angle between A and B, the scalar product is given by A dot B equal to dimension AB cos tangent, where tangent is between the 0 degrees and 180 degrees.